North America needs an aqueduct. Specifically, the states need a national aqueduct system so that flooding in the southeast can be used along the drought-infested west coast. The continental divide separates these two regions. Canals are man-made rivers with reinforced banks to prevent erosion, like this one snaking through Arizona. The ancient Romans built aqueducts throughout the kingdom to move water to drought-ridden areas. An aqueduct is just a raised canal, which sometimes passes through mountainous terrain. The red highlighted area in our map is actually not the Great Divide, but a visible elevation marker of 1,000 feet. Thus, a 900-foot tower in South Carolina would raise water to an elevation of 1,000 feet above sea level. This could be connected to a tower in Montana, close to the red boundary of our map, and the reservoir there would not be a tower, but more appropriately called a lake, which is at the same elevation above sea level as the tower in South Carolina. Towers in Mississippi, Louisiana, Alabama can be connected to towers in the heartland. Water now flows naturally between these sites, driven by the force of gravity, keeping the reservoirs, separated by thousands of miles, in balance through underground piping. Another lift at the Montana and Texas locations can drive the water over the divide to connect east to west. There are a number of different pumping methods that employ natural resources, animal, wind, even currents dating back to 700 BC. Pick one. To raise the water into the towers during normal conditions. In the event of flooding, cities already have very large powered pumps. Some of the exhaust water can be put into the national aqueduct system. Why waste it? Farmland in Northern California no longer has to compete with cities in the south for the limited water resources in an area susceptible to severe drought. The aqueduct system can shadow the interstate highway system to take advantage of existing bridge work. Water from flood zones can now pass through braided underground piping at very low cost to reach the drought-even desert areas. In the short term, the aqueduct system provides much-needed jobs, both installing pipes and valves, but also increasing manufacturing of heavy equipment for earth moving and transport. Parts, labor, and maintenance continue to provide long-term employment. Water is now a commodity, sold from states rich in the resource to states that have outgrown their natural supplies, like California and Nevada, specifically the cities of Los Angeles and Vegas, that are always a few months away from a biblical disaster. Gravity is the main driver, generating a steady flow at low operating cost. Emergency conditions can engage powered systems to speed up the transfer, even catching El Niño water in Southern California and pushing it northward to replenish natural reservoirs that are at dangerously low levels. The spillways and other outlets of hydroelectric power plants can be repurposed to drive water into the aqueduct system. Value is difficult to calculate, but consider, farmland in California provides half the nation's produce. The nation cannot afford to lose it, especially when there is an abundance of fresh water available.